for maybe 20 minutes, and it runs hand in hand with section 1.4 because they're both required. And when you're looking at section 1.3, it starts on page 21. You see here in the book, out of the way. Okay, it is centered around rate of change or slope. Okay, and what we have to imagine is that we're dealing with linear functions. Okay, a linear function, linear meaning line, function being that one element of the domain corresponds to exactly one element of the range. Okay, so it's just lines. There's multiple ways you can find the slope. Okay, beautiful thing about a line is if you're trying to find the slope graphically, algebraically, it's always constant. Okay, that's one of the beautiful things about a linear equation is it has a constant rate of change. Okay, and you can see it here. The rate of change is based upon the change in the y values over the change in the x values. Okay, it's also sometimes referred to as delta y or delta x. And what they give to us is this sets up what's known as the slope formula. Okay, I wouldn't be surprised if you've already seen this. M is the variable that is most common referred to or used when we're talking about slope. But m is equal to y2 minus y1 over x2 minus x1. Okay, and what we need to do to find our slope is we need to find the difference in y. So our second y variable versus our first y variable, subtracted. And then that'll give you the change in y. And then the change of x is taking your second x coordinate, subtracting the first x coordinate. Okay, it labels them x2 and x1. And the way that we make the determination is we read graphs like we read a book. We read them from the left to the right. Okay, if you have a positive slope, meaning that it's increasing, that means that your graph is going to go up as you move farther right. Okay, if you have a negative slope, your graph is going to go down as you move farther to the right. Okay, you can find the slope by plugging them in, but the key thing is y2 needs to be matched with x2, y1 needs to be matched with x1. We don't want to mix and match points. Okay, so we're going to do a couple examples just real quick. Okay, and then we'll be on to section 1.4. You do have problems about finding the slope here. So it says recreation, the graph at the right shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? So we have the point 7,252, where 7 is our x value corresponding to time in minutes, and we have a point 3,108. Okay, so like I said, we want to look at this as being left to right. Helps if I have my screen shared. We're working on this question. We have 3,108, 7,252. Okay, so these are the values that I want to use. And the beautiful thing is, it doesn't matter which one we really choose as x2 and y2 and x1 as y1. We just got to make sure that if we put 3 first, 108 is the first y value. If we put 7 first, 252 is the same y value. Okay, and I'll show it to you both ways. Those are the points we're using. So we have 3, 108, 7, 252. Okay. So there they are in ordered pairs. Now what we do is we would plug them into our equation. Like I said, it doesn't matter which one we declare as x1 or x2 as long as they match up, and we'll do them both ways. So for y2, I'm going to put 252 because that's the point that's farther to the right. y1 is going to be 108 because that's the point that's farther to the left. Okay, and then I'm going to have 7 minus 3. My y values, my x values. Okay, now I carry out my subtraction. Okay, 252 minus 108 is 144. 7 minus 3 is 4. Okay, believe it or not, that's an acceptable way to present the slope, but this can be reduced. Okay, 4 goes into 144 36 times. So this would simplify down to 36 over 1, which would give us a slope of a positive 36. As it correlates to the problem, we're talking about filling a swimming pool, and they want to know what the rate is that we're filling. So what this means is that we're filling at 36 gallons per minute, where the change in y represents how many gallons did we add, and the change in x represents how much time has elapsed. Okay? Like I said, it doesn't matter which one we plug in or which one is which, they just have to be organized. So even if we wanted to go 108 minus 252 over 3 minus 7, we would still equal a negative 144 over a negative 4. Now they're negative because I'm doing it reversed. But once again, negative and the negative cancel themselves out to make a positive. And 4 still goes into 144 36 times. So this would still be equivalent to 36 over 1, or 36 gallons per minute. Okay, so the key thing when you're using the slope formula is that this side needs to match your ordered pairs. Okay, your ordered pairs are together. Okay, that's one of the most common mistakes that you make. And really, that's kind of a big mistake. So if we were to make that mistake, we'll say we have 108 minus 252 over 7 minus 3. So again, we're going to get a negative 144 over 4. But in this case, we only have one negative. So that would correspond to a negative 36. Right? That doesn't necessarily work. And you can see it completely alters our answer. So we have to be detailed about which y values we are pairing with our x values. We don't necessarily have to be strategic in plugging them in. We just have to be detailed. Okay, make sure that your ordered pairs are paired up. And like I said, we have a positive slope. Okay, you can always tell a positive slope on a graph is if we're moving from left to right on the x-axis and our graph is increasing. Okay, so a positive 36 makes sense in this case. Whereas a negative value or a negative slope, as we move to the left, it would be decreasing. Okay, so that's how we find the slope if we are given the ordered pairs. And like I said, it's pretty simple. Pretty simple, pretty easy. Other key terms that correspond to finding the slope, or when they're asking you to find the slope, they might ask for the average rate of change. Okay, average rate of change, same exact type of question. They're asking you to find the slope. Okay, we don't have to overcomplicate these. And if I hope I'm right, I'm assuming that most of this should be a review from Algebra 1, at least the slope part. Okay, that's another one. Okay, any questions on slope before I go forward? I can knock those out real quick. Okay. If you do have questions, make sure you're using the chat function. Also, I'll be available via email. It should be pretty simple. Alrighty, but now we are off to our slides. And today we are actually going to go over the 5-minute check. because that's always corresponding to the slope here. So it says find the rate of change for the data. We have the gasoline in the tank and the distance per mile. So when we're given a total or totals like this, we want to determine what would make sense to be our Y value, what would make sense to be our X value. Okay, and the way that we do this is we'd have to determine which is dependent upon which. So is the distance dependent upon the gasoline in the tank? I mean, it gives us an idea of how far we could go, but those two, that really is kind of backwards, right? The farther we go, the less gasoline we should have. So the distance should be our X value, and the gasoline in the tank should be our Y value. Or I might have said that backwards. No, distance is Y value, gasoline in the tank is X value. Okay. So to find the average rate of change, we want to pick out some of these points. Okay, I like using zeros because they're very easy, and then we can run it through our slope formula or average rate of change. So I'm going to use 15.0 and 12.66. So on the top for Y1, I'm going to plug 66 in, or for Y2, I'm going to plug 66 in. For Y1, I'm going to plug in 0. And then on the bottom, I'm going to plug 12 and 15. And once again, the key is that our ordered pairs match up. So this is what I'm working with. Here I have 66 minus 0, or our change in Y, and 12 minus 15, or our change in X. 66 minus 0 is easy. 66 minus 0 is 66. 12 minus 15 gives me a -3. I have one negative value, so my answer is going to be negative. And this will simplify down to a -22. Okay, so now we'd look, and we'd find that we get a -22 miles to the gallon. Which should correspond to answer A. So once again, average rate of change, always talking about the slope formula. Okay, find the slope of the line that passes through points 2.395 and 3.820. This one's handled the exact same way. It's just a little confusing because they have decimal points. So, and it doesn't matter which one we plug into Y2 and X2, as long as they are matched up. So on the top, I would have 20 minus 9.5 and 3.8 minus 2.3. Okay, using the slope formula. So that's what I'm working with. So 20 minus 9.5 is 10.5. And 3.8 minus 2.3 is 1.5. This also can be simplified. Anytime that we can simplify a fraction, we must do so. Okay, 1.5 goes into 10.5 7 times. So this would be equal to a slope of 7, which corresponds to answer C. Okay, this one's a pretty easy one. I got a couple minutes. I want you guys to try it by yourself, and I want you to put which letter you think it is into the chat. Okay, plug which letter you think it is into the chat. You have the 0.35 and -6.5. Okay. Wait, no. Okay. Okay. One more minute. Good, Aiden. Good, Alexandra. Kayla. Good, Jonathan. Good, Pablo. Good, Jazzy. Oh, I'm struggling. Okay, Peyton, we're going to go through it. Okay. Okay. See a couple question marks. See a couple that are saying they're confused. It's all right. It's okay. I'm kind of putting you on the spot here. Key thing is have confidence in it, right? Have confidence in your answer, know what we're doing, and being able to work through the process. That's the key. Be perfect. All righty. So we're given 3, 5 and negative 6, 5. And remember, our slope formula looks like this: y2 minus y1 over x2 minus x1. The keys being that these 2 points are in an ordered pair, these 2 are in an ordered pair. We don't want to flip-flop. Okay? Also remember that in our ordered pairs, when they're presented, the 5s are the y. The first x value is 3. The second x value is negative 6. So the x is the first number. The y is the second number. So we're going to have 5 minus 5 on the top, and then 3 minus a negative 6 on the bottom. Okay? So 5 minus 5 over 3 minus a negative 6. 5 minus 5 is 0. And 3 minus a negative 6 is 9. So this, once again, can be simplified down to 0. Okay, so the correct answer should be B, 0. Easy thing to remember, or what we need to remember with whenever we're using fractions, is that this is parts of it and this is the whole. Okay, we can have a 0 in the numerator because that means you have 0 pieces of like a pizza, right? Pizzas come in 8s, slices of 8s. So if you have a 0, it means that you didn't get a piece of pizza. You got 1, that means you got 1/8. You got 2, 2 over 8 would simplify down to a quarter. Okay, so this is how many pieces we have. This is how many it would take to make a whole. Okay, what we cannot ever have in mathematics is a fraction that looks like that, 9 over 0. You're saying you have 9 pieces of a whole that has nothing. Okay, that's what's known as undefined. Okay, and undefined is bad. Okay, undefined is bad. If we were trying to graph it, it means that we have a vertical line, okay, for a slope. So each and every one of our x values, or we would only have one x value and an infinite amount of y values. Okay, I got a couple more chats coming through. Peyton, you get to choose, right? you get to choose, and as long as your pairs, your ordered pairs, are in the same position on our fraction, it's going to break down to be the same thing. So we get to choose which one we get to put in for x2. Just whichever one we put in for x2, the corresponding y value better be in y2. Okay, we run into issues if we try to pair x1 with y2. Okay, and it'll break itself down that way. And you'll see it when we go through a little bit more. Okay, but we really get to choose. The way that I like to do it is I like to work left to right. Okay, so in this one, if we're imagining an XY graph, right? If we're imagining an XY graph, we'd have an origin, and -6 would be way over here, and 3 we would cross back over the y-axis to be on the positive side. So working left to right, we would come across -6 first before we came across 3. That's why I always put my higher x value or the greater x value in x2 and the lesser x value in x1. Okay, but the slope formula will work itself out either way you do it, as long as we're doing it correctly and we have our pairs matched up. So the answer is B, 0. Okay, here's another way that we can find slopes. Graphing, it's an easier way. I wouldn't even really say it's easier because we have to estimate. It's always better to check it algebraically, but you might have heard the term rise over run. Okay, so first thing I want to do is I want to eliminate some of my multiple choice answers. You can see I have a -3, -1/3, 1/3, and 3. So from this, are there certain choices that I can eliminate already just from looking at my graph? And the answer to that would be yes, right? My graph goes down as I work to the left, as I work to the right, right? So we know it can't be a positive slope. Okay, the farther I go right, the more and more my graph decreases. So that just doesn't hold water. So we know it's not C or it's not D. Okay, but now it's time to determine between A and B. Since we have a picture of the graph, I want to find where my holes are. Okay, and what I mean by holes is the points where I actually cross over a grid line. So if you look, I have a point here at 2, -3, which is right about where my cursor's at right here. 2, -3. And then if I'm looking, it looks like I have another point at -4, -1. I can't quite tell if that's -1, -2. I'm a little skeptical about that, so I'm going to use -4, -1. Okay, because once again, I'm trying to find my holes. Okay, I don't want to be estimating, oh, well, that looks like it's about a quarter down from -1, because that's very, very tough. So we want to find the areas where it actually works. Okay, now that I've picked my ordered pairs, I would run it through my slope formula. So once again, I need to make sure that I'm all matched up. So on the top, I'm going to go -3 minus a -1. Okay, and then on the bottom, I'm going to have -4 minus 2. -3 minus a -1 is really, you're adding 1 to a negative. So that's going to give you -2. -4 minus 2 gives you, I might have did that wrong. +1, -2. 1 minus 2 should give you a -6. Did I write it wrong?
It's supposed to be 1.
What's up?
On the top, so you said posted numbers.
Yeah. Ugh. See, and that's a mistake that we make. X2, X1, Y2, Don't mess it up next time. -3 minus -1. Yep. And 2. There we go. Thank you, Mr. Brock. I had it backwards. So that's going to be -2 over 6. And you see it's pretty easy to get yourself confused. That way I just made a mistake. Andrew was able to help me out. I come out with a -2 over 6, which will simplify down to a -1 over 3. So my answer should be letter B, -1/3. How did I get the 4? I picked it out from the graph, Peyton. Picked it out from the graph. -4. Right there. Right there. -4, -1. So when I'm just using grid marks, and remember, try to find your holes because you don't want to estimate decimal points. Okay, so that's slope. Slope is the key thing when you are dealing with linear equations, okay? It determines how quickly your graph is increasing versus how quickly it is decreasing. But now what we're going to do is we're going to take that slope and we're going to actually write linear equations, okay? So things that we can graph. So we're going to write an equation of a line given the slope and a point on the line. We're going to write an equation of a line parallel or perpendicular to a given line. So your vocabulary, slope-intercept form. This is probably one of the most common equations that you've had experience with. Okay, I'll leave up the slope formula. y2 minus y1 over x2 minus x1. It's been a long day. Okay. Slope-intercept. Can be expressed as y is equal to mx plus b. Okay, and it looks exactly like this that we have on our board. Okay, or as y is a function of x. Okay, you should have already seen this before. If you haven't, just remember that m right here corresponds to the slope of the line. Y would be your output value. Okay, so we're going to find y variables. This x is where we would plug x coordinates in. B is known as the constant. Okay, or the y-intercept. Okay, for any linear equation, the constant at the end is where we will cross the y-axis. Okay, and that's because to be on the y-axis, we'd have to have a 0 for x. So when we plug in a 0 here, it's going to cancel those out and make that 0. Right? Anything times 0 is 0. And then plus b would give you how many coordinates up. If it's minus b, it's how many coordinates down. Okay, that's why it's called slope-intercept form. M is your slope, b is your y-intercept. Okay. The next formula that we are going to be using almost constantly is known as point-slope form. Okay, and point-slope form breaks itself down as y minus y1 is equal to m times x minus x1. Okay, and I'll show it to you right here. It's right here. Okay, once again, m is the slope. Okay, this y1 is the y value of the coordinate pair. So the point that they give us. This x1 is the x value of the coordinate pair. This x would be the input variable so that we can plug in more and more x values. This y is the output variable. So as we plug in more and more x values, we would get more and more y values. But we would use this when they say, hey, write the slope of an equation that passes through this given point with this slope, or write the equation of a line that passes through this point with this given slope. Y1 is the y value of the coordinate. X1 is the x value of the coordinate. M is always the slope. Okay, I'll give you guys a couple seconds to write that down. I believe that's all the new vocabulary that we're going to have. Oh, no, we've got two more. Dang it. And you will see them again. All right. Last two vocabulary terms. These you definitely covered in geometry. Okay, it is parallel. Parallel is talking about two parallel lines. Imagine them like railroad tracks. Okay, parallel lines never cross. Okay, they never touch. The only way that you can have two lines be parallel to themselves in the xy plane is if they have the exact same slope but a different y-intercept. Okay, exact same slope, different y-intercept. Okay, perpendicular lines. Those are lines that intersect at a 90-degree angle. Okay, it is perpendicular if it intersects at a 90-degree angle. The way that you get to that is you use the opposite reciprocal slope. Opposite being if it's positive, it turns to negative, and then reciprocal takes a whole number and flips it to a fraction. Or your numerator now becomes your denominator, and your denominator now becomes your numerator. Okay, but you will see that as we get to it. Okay, they're explaining slope intercept again. Like I said, B is always your y-intercept. That's because when we plug in 0, this m times 0 is going to equal 0, and we're just going to be left with B. Okay, slope intercept form. Okay, write an equation, slope intercept form, write an equation, and slope intercept form for the line. So first thing we got to do is we got to find the slope. Okay, so we're going to use the grid lines to help us count. So it's not marked any different, so we have to assume that we are counting by 1. So if I go to the left one, that's -1. My y value is 1, 2, 3, 4. So I have one ordered pair at -1, 4. And then finding the other point or the other place that I cross exactly on a grid line. If I go from the origin, I go right 1, 2, and up 3, I have the point 2, 3. Okay, so we are using -1, 4 and 2, 3. So we want to plug it into our slope formula. Okay, you can see they've declared 3 as y2, 4 as y1. So on the top, we have 3 minus 4. And then in the denominator, we have 2 minus a -1. Okay, once again, the key being that these two are paired up and these two are paired up. Okay, 3 minus 4 is -1. 2 minus a -1 is going to give you 1/3. So we would have a slope of 1/3. Or a -1/3. Okay, Now they want us to do it in slope-intercept form. So we're going to take our y equals mx plus b, and we're going to plug them in using one of the points. Okay? So it doesn't matter which point we use, we just want to plug it in. Okay? And this is to find the y-intercept. So they've chosen to use the point -1, 4. Once again, we found that by using the grid lines. So they've plugged it all in, and then they've simplified. So once they've simplified, we have a positive 1/3 plus b is equal to 4. Okay, so once again, they plugged it all in, and now it's just solving for b. So we have 4 is equal to 1/3 plus b. We need to isolate b. Okay, we need to isolate b. So we're going to subtract 1/3 from both sides. So on the right, we're going to be left with just b. And on the left side, we're going to be left with 3 2/3. So 3 2/3 is our y-intercept. And then it just comes down to plugging it in. Okay, the areas that we're going to plug in, we're going to plug in the slope for m, and we're going to plug in our newly found variable of 3 2/3 for b. So our equation is going to equal y is equal to 1/3 x plus 3 2/3. Okay, making sense how we can use this slope-intercept form? Like I said, you should be pretty familiar with it. The one that you're probably not familiar with is point-slope form. But in all honesty, I like point-slope form. There they leave it as an improper fraction. So 11/3 is equivalent to 3 2/3. Okay, write an equation in slope-intercept form for the line. Okay, this one, all we really need to do is we really need to just find the slope. Okay, and the reason being, I'm coming across it like a multiple choice question, like how you take the SAT, the PSAT, however you want to look at it. They give you quite a bit of information. So first being the b value. So like I said, in the equation, y equals mx plus b, our b value is always the y-intercept. Where do we cross the y-axis? Here, we cross it out. We cross it at the point 3. Okay, so 0, 3 is one of our points. Okay, and 3 is the value for b. So it doesn't help us eliminate any, it's just a matter of finding the slope now. So we have 0, 3. And it looks like if I go from the origin working to the right, I go 1, 2, 3, 4, 5, 6, and up 1. So I have the point 6, 1. Now I just need to plug it into my slope formula. Okay, and I'm going to have 1 minus 3 on the top over 6 minus 0 on the bottom. That gives me a negative 2, 6, which simplifies down to a negative 1/3. So now I just want to find the answer choice that has negative 1/3 for the slope and 0.3 for B, which should correspond to letter D. Okay. Here's the key concept once again, slope-intercept form. This is vital. Okay. You should be very familiar with slope-intercept form. It's also the any linear equation is given to you in this format. Okay, y equals mx plus b. They might set it up and they might try to confuse you where they have a coefficient associated with y. Okay, in order to be in slope-intercept form, y needs to be wholly by itself. So if they give you any equation that doesn't look like this, to get it into slope-intercept form, we have to solve it for y, or we have to isolate y. Okay, and you'll see that on a couple examples in the book. Okay, here, write an equation given slope and 1 point. This, we could do it through slope-intercept form. I would prefer to do it through point-slope form because it's a little bit easier. Very simple. Okay, there's your slope or your point-slope form. Give you a second, and I'll actually work this one out. Okay, and the only thing I'm doing is I'm setting up my equation, plugging in the given information that they've given. So y minus a -2, that's y1, is equal to a -3/5 times x minus 5. Okay, and that is x1, and n is always this one. Here we go. So once we plug it in, it's going to look like this. Y minus a -2 is equal to a -3/5 times the quantity of x minus 5. Okay, first thing that we can do here is we can simplify this down. Okay, on the left side, anytime I'm subtracting a negative, that is really adding a positive. Okay, on the right side, first step that I have to do is I have to distribute across. So I have to take this -3/5 times x, but I also have to take it times 5. -3/5 times x gives me a -3/5 x. And then -3/5 times 5, or -5, should give me +3. Okay, because they're both negatives, I'll write that a little bit bigger. Okay, once again, we multiplied here, and we multiplied here. Trying to stay out of your guys' way, that way you can see it. Okay, multiplied to get a -3/5, multiplied these to get a +3. Negative times a negative gives me a positive. Okay, once I'm at this stage, now to get it into an equation that I can actually use, I have to isolate the y value. Like I said, it's always y equals. It's never y plus 2 or y minus 2 or 6 times y is equal. It's always just y. So to do that, I would minus 2 from both sides, and I would be left with y is equal to a -3/5 x plus 1. Here's the book walking you through the same exact thing. Okay, first step, plugging it in. Okay, remember y1 and x1 are reserved for the coordinates. M is always reserved for the slope. Okay, then they simplify it down. Okay, and they simplified by distributing this -3/5 x into these parentheses. So -3/5 times x, -3/5 times a -5. That does give you -3/5 x plus 3. Now we have to isolate the y value. So we subtracted 2 from each side. So now we are y equals -3/5 x plus 1. And that is the equation. And you'll see, once we do and we carry out slope, point-slope form, we'll always end up back in slope-intercept form. Slope-intercept form is the general form for all of our linear equations. Okay, it's always set up as y equals mx plus b. Okay, here it says, what is an equation in slope-intercept form for the line that has a slope of 2/3 and passes through -3 and -1? So once again, we're going to use our point slope. Okay, and it's going to set up as y minus a -1 is equal to 2/3 times x minus -3. Okay, once again, we can simplify it, make it a little easier. On the left-hand side, y minus a -1 is equivalent to y plus 1. Okay, here we have negative minus a -2, so that's really x plus 3. So once again, I'm going to distribute. So 2/3 times x gives me 2/3 x. Okay, and 2/3 times 3 is going to give me a positive 2, not positive 3, Mr. Burns. Positive 2. Okay, now it's time to isolate the y variable. So we minus 1 from both sides, and we will be left with y is equal to 2/3 x plus 1. Okay, and that should correspond to answer A from the PowerPoint. Share my screen. Always got to share the screen. Okay. Any questions so far on point slope form, slope intercept form? All righty, away we go. Okay, here's one of the more tougher problems. It's only tough because we got to find our slope first. Okay, once again, this gives us a benefit because once we find the slope, we should be able to eliminate a couple of answer options. So running it through my slope, I have 2 -3, so I'm going to go -3 minus 7 is equal to 2 minus a -3. Okay. Setting up my slope formula. Make sure I did it right. -3 minus 7 is equal to a -10. 2 minus a -3. Okay. -10/5 can be simplified down to a -2. So my slope is equal to -2. At this point, it's a multiple choice question, right? Do I have enough information to answer it? Yeah, right? There's only one option, or there's two options with a -2. So I know it's got to be A or D, right? That's the main point to figure out whether it is. Get you out on maps. Okay, Des, I'm going to suspend your test. Or here you go. I'm going to set it so that you can resume. It's because you were rapid guessing there. Okay, you should be pretty good. I think you only have like 1 or 2 questions left. Why? Let her take the test. Stop it. All right, you are completed. Good job. Good job. Okay. Back to where I was. So first thing we got to do is we got to find the slope. We did find the slope of -2. Now what I'm going to do is I'm going to take this and I'm going to plug it into my point slope formula. And it doesn't matter which point I use, both of them are going to work. I want to use 2, -3. So I have 1 minus a -3 is equal to a -2 times x minus 2. Okay, once again, simplify. The left side turns into y plus 3. -2 times x is -2x. -2 times -2 is a plus 4. Now I got to isolate my y value, so I minus 3 from both sides. My equation is y is equal to a -2x plus 1, which should be answer D. Get me back to where I can share my screen. There's so much flipping back and forth, man. It's brutal. Okay, book's going to walk you through it as well. So given 2 coordinates on 2 points of the line. First up, find the slope. Right? We ran through all of that, and we found that our slope is -2. Okay? So that eliminates choices B and C. We're down to A and D at this point. Write an equation, use either ordered pair for x1 and y1. Plug it in. Simplify. So y plus 3 is equal to a -2x plus 4. Now we need to isolate the y variable. So we're going to subtract 3 from both sides. And we are left with y is equal to a -2x plus 1, which corresponds to answer D. We're not going to go through that one because we got to talk about parallel and perpendicular lines. Okay, like I said, parallel lines, we want to think railroad tracks. These are things that never cross. They extend and they extend and they extend all the way out as far as you can imagine, but they never cross. Okay, and the only way that that is possible is if they have the same slope with a different intercept. So here we have y equals 2x plus 5, and here we have y is equal to 2x minus 1. So same slope or value of m, but different intercepts. They have to have different intercepts because if they had the same intercept, they would be the same line, okay, with the same slope. And that does not correspond to parallel. So now we're off to perpendicular lines. Okay, perpendicular lines. If and only if the product of the slopes is -1. Or in other words, we want it to be the opposite reciprocal. So here we have y equals 3x plus 2. So positive 3 is our slope. And then here we have y is equal to a -1/3 x minus 4. -1/3 and 3 are opposite reciprocals. Okay, if we were to multiply those, they would equal -1. So 3 being a constant, understand that we can always write this as a fraction. It's just 3 over 1. Okay, 3 over 1 is equivalent to 3. And we're going to multiply that against a -1/3. Okay, multiplication of fractions, we multiply straight across. 3 times 1 is 3. 1 times a -3 is -3. This simplifies down to a -1. These are opposite reciprocals. Okay? So just for a whole number, know that it can be written as a fraction over 1, or 1 in the denominator. All righty then. Dang it, man. I'm a captain, not a poor boy. All right, write an equation in parallel or perpendicular line. It says write an equation in slope-intercept form for a line that passes through 3, -2, and is perpendicular to the line whose equation is y is equal to a -5 x plus 1. First thing, we want to be perpendicular, so we have to find what is the opposite reciprocal of -5. Okay, -5 written as a fraction is -5/1. Okay, the opposite reciprocal, and write down point 2, the opposite reciprocal of -5 is a positive 1/5. So simply because we know the definition of what a perpendicular line is, we are given the slope. Okay, if it asks for a line that's parallel, we would use -5. But we're using perpendicular, so we have to be opposite reciprocal. And then we want to plug it into our slope, our point slope form, which once again is y minus y1 is equal to m times x minus x1. Plug it in, carry it out. So y minus -2 is equal to 1/5 times x minus 3. Okay, simplifying the left side, y minus a negative turns into y positive, y plus 2. Distributing my 1/5 across, 1/5 times x is 1/5 x. 1/5 times a -3 is -3/5. Okay, now the tricky part is I have to isolate my y value by subtracting 2 from both sides. Okay, here I'm dealing with fractions. Okay, when you are subtracting a fraction, they have to have the same denominator. Okay, so in other words, I have to get this 2 to be equal, but I have to have a 5 in the denominator. Okay, the easiest way to do that would be to multiply it by whatever the denominator is. So this is really a -3/5 minus 10/5. Okay, 2 times 5 is 10. If I express that over 5, I have common denominators. I subtract those, get a -13/5. Yep, because a negative minus that. So my equation is equal to y is equal to 1/5 x minus 13/5, or y is equal to 1/5 x minus 2 3/5. Both should be equivalent. Okay, so the key with perpendicular parallel lines is that is where we find our value for m, and they give us the equation for what they're supposed to pass through. So slope of the given line is -5. We want to flip it to its opposite reciprocal, which is 1/5. Okay, and then use point slope form for the ordered pair 3, -2. So they plug it in. They simplify. Okay, so on the left, y minus a -2 turns into y plus 2. The distributive property yields 1/5 x minus 3/5. Okay, subtracting 2 from each side. Once again, since we are subtracting using a fraction, we must find the common denominator, and that is how we get -13/5. All righty, that's what I got for you. Okay, parallel lines, perpendicular lines. It's not necessarily the most difficult thing in the world. It's just you need to know what the definitions are. Okay, a parallel line will always have the same slope. Okay, if two lines are parallel, they will have the same slope. If they are perpendicular, they will always have the opposite reciprocals. Okay, your homework today comes in 2 different activities. I did it so that I could export. Seesaw won't let me upload 2 PDFs on the one activity, so I just had to split it out. The first portion comes from section 1.3, and that's on page 25. And then the second section comes from page 32, which is section 1-4. Numbers are page 25, 12 through 28 evens. And then on page 32, it is 10 through 34 evens. So roughly about 18 problems. I wanted to show you guys something though, because I don't think we're using McGraw-Hill to the capacity that we could. Okay. So when you're on your McGraw-Hill book, and I know that the PDF is so much easier. I know it's so much easier to use because it's right there. But within your McGraw-Hill book, if I go to one of the pages, which is page 25, and say I get confused, okay, and I get confused, it's late at night, you don't want to bug Mr. Burns, or you're just scared to send me an email, I don't know why. But you see this little button down here? This is called the tutor. If you click this button, it brings you into videos.
Hello, this is Mrs. Hyman.
That will walk you
Find the
through how to
slope of
find
the line
slopes.
shown.
Okay. So once again, that is, I don't want to, yep. That is this little purple button that looks like it has a bubble. You can see it has a pop-up that says tutor, not tuber. This is a glossary or a vocabulary glossary. This brings you to certain tools, like you have a graphing tool in there. Here's a video about starfish. I'm not sure why they chose starfish, but they did. And then here is the Geometry Sketchpad. The Geometry Sketchpad probably won't work on your Chromebooks. Probably the most useful tool for you guys is the tutor. Okay? And you will find it's on every single page. So even if I go to section 1.4 and I get to page 32, I click here on the tutor button, brings me to videos, and I can watch these. They also have them recorded in Spanish. Okay, pre-calc doesn't have that. Hey dude, welcome to calculus. All right, I assigned your activities. You're going to see two of them, part 1 and part 2. Part 1 is page 25. Part 2 is page 32. I'm done lecturing. I'll leave the Zoom call spinning.